everybody. I'm Chris Carberry, CEO of Explore Mars. Welcome to the H2M webinar series. Today's show is called Hubble, 30 Years of Awe and Wonder. Before I introduce the panel for today, I have one short announcement. We hope you'll join us on Thursday at 1 o'clock Eastern Daylight Time for a session called Full Steam Ahead, the storied partnership of space and Hollywood, featuring Jonathan Frakes, well known from Star Trek as Commander Riker, and that'll be facilitated by astrophysicist and Star Trek consultant Aaron McDonald. So I hope you'll all be able to come on. I hope you'll join us on Thursday at 1 o'clock. And since this webinar series is part of our Humans to Mars Summit programming, I also like to thank our sponsors for the Humans to Mars Summit, including Aerojet Rocketdyne, Lockheed Martin, Northrop Grumman, ULA, Paragon, MDA, the National Institute of Aerospace, the Science and Entertainment Exchange, and many others. And we will highlight them all over the next few weeks. And if you enjoyed these webinars and our other programming, we hope you'll support us. Any level of giving would be greatly appreciated. And if you have any interest in sponsoring our webinars, please contact us at info@ExploreMars.org. So thank you very much for those who have given. Now to move on to our fireside chat, today's session will be facilitated by our friend Matt Kaplan, host of Planetary Radio, and he'll be chatting with five-time shuttle astronaut, AKA the Hubble Repairman, John Grunsfeld. And before we get moving, I've known John for over 10 years. I remember before his last Hubble telescope repair mission, I was touring around Goddard Space Flight Center with him and David Schumann. And there's this piece of equipment John used to practice, his Hubble repairs on. I think it was like underneath the stairway at Goddard. And I was able to put on the space glove and have the power tool. I was amazed how complicated that would have been, just standing there in 1G without a spacesuit, and just imagining him being up there for 8 hours trying to do this incredibly complicated task. I was definitely in awe. So this was one of the most Herculean tasks I can ever imagine. So at any rate, I'd like to introduce our panel, Matt Kaplan and John Grunsfeld. Welcome, gentlemen.
Thank you, Chris, very much. And boy, no pressure there, right? I mean, no pressure in the glove like John had to deal with when he was doing it up there for real, right next to the Hubble Space Telescope. I am thrilled to be back for the third of these live conversations on behalf of Explore Mars. I am Matt Kaplan of the Planetary Society, the host of Planetary Radio. And I will say up front that one of the reasons I'm thrilled to be talking to John is that I'm going to repurpose some of what we talk about today in next week's episode of Planetary Radio. So that'll be another place to catch it. Audio only, you have the benefit or the handicap in my case of being able to see me, but I'm very glad that you've got John on screen as well. It's likely that there isn't another man or woman who knows more about the Hubble Space Telescope than John Grunsfeld. It is certainly true that no one has done in space more with this most famous scientific instrument of all time. He is an astrophysicist who has taught and conducted research for some of the finest institutions on our planet. He flew on 5, count them 5, shuttle missions. 3 of these were dedicated to maintenance and upgrade of the Hubble, or HST. He spent more than 58 hours outside in extravehicular activity in those gloves that we've heard so much about. Later, he would become NASA's chief scientist and then the agency's associate administrator for the Science Mission Directorate. This meant that he had responsibility for well over $5 billion worth of missions, projects, and research. He finally retired from NASA 4 years ago. That was also when I met John. It was at the annual Space Symposium in Colorado where, and we're going to pop this up, as you can see, we compared space ties. And I think that's going to show up here in a second. And Chris Carberry, if you're still around, I think you might have taken this photo for us, Chris, because it's definitely not a selfie.
I don't know. I seem to recall watching it, so I either took it or stood nearby.
With a pretty nice background, too. Okay, well, I guess that's enough of that. John, I know that you have some great slides that you want to share with us before we get to the questions that are going to be pouring in from our viewers. Actually got one offline that we might lead off with, and then I've got some questions for you of my own, but I want to confirm something first. Is it true that you were the last person to touch the Hubble?
Well, that's a matter of great debate because, of course, I was wearing gloves. And, you know, I'm a human spaceflight guy. I'm wearing gloves today, as a matter of fact. And so apparently that's my normal attire. I'm not wearing a tie today. So you went on the tie department. But Megan MacArthur claims to be the last one to touch the Hubble because her job on board was robotic arm operator. So she touched everything with the shuttle robotic arm. And of course, we did have to deploy the Hubble. But it is true that, you know, as far as human hands, at least in gloves, I was the last person to touch the Hubble.
Well, whether it was through thick pressurized gloves or not, I think you have described yourself as a telescope hugger, aren't you?
I am one of many Hubble huggers over the years. And, you know, this year we're celebrating quite the milestone, and it's related to hands as well, but this is the 30th year of Hubble being on orbit. It was launched in 1990. April 24th, 1990 was the launch of Hubble. So we're just slightly over 30 years. Now, why do we celebrate, you know, decades in space? And again, it's because we have 10 fingers, so we celebrate things in decades. If we had 8 fingers, it would be different. But it's still a milestone. Very few observatories, very few satellites make it 30 years on orbit. And it's a testament to the incredible designers, the people who designed the Hubble Space Telescope, and the policy people who had the insight to make a serviceable observatory. You know, Hubble is still basically state-of-the-art on orbit and doing breakthrough science because we were able to go up and put new scientific instruments in and fix things that break. Otherwise, Hubble would no longer be viable now. So it's a pretty incredible story, and an optimal marriage of human spaceflight and science robotic spacecraft to be able to allow Hubble to unravel the mysteries of the universe.
So serviceable, designed to be serviceable, but not always in the most easy way, as I bet you will get to. If you don't in your slides, we will later, because sometimes it could be quite a challenge, as we've heard from you and others who completed that spectacular work on the Hubble Space Telescope and made sure that it is still able to do great science for us today. Why don't we go ahead into your slides, and then we'll follow that up with questions, more from me and some from our viewers.
Sure. Well, Chris Carberry, thank you very much for inviting me to tell a little bit of a Hubble story, and then we'll get to questions. Chris did try one of those repairs that Hubble was not designed to be repaired that we had to do, and I think that's, you know, a very important thing to bring out right from the start is that what we've learned from repairing and upgrading the Hubble Space Telescope is just about anything that you can do on the ground. We can learn how to do in space. Maybe a little bit harder in the spacesuit, but people are really good tool builders, and we figure out a way to do it. And when we go to Mars, we're going to have to really exercise that a lot, because it's going to, you know, Mars exploration presents challenges that we cannot anticipate now. And the fact that we can do these difficult repairs on Hubble, I think bodes very well for human exploration. I do want to, at Matt's urging though, you know, mention, you know, that human exploration and the first American to orbit the Earth was John Glenn. And he was just a tremendous guy. He had two space flights, you know, one on Mercury that we're all very familiar with. And of course, at the age of 77, he flew on the Space Shuttle. And that mission actually carried some hardware that was a test flight for our Hubble mission in 2002. And, you know, fortunately, he lived a very long and, you know, productive life, both serving as an astronaut and serving as a public servant. But behind John Glenn, and I think responsible for, and John, I think would agree with this completely, responsible for a significant fraction of his success in life was his wife, Annie. And Annie was just absolutely the most wonderful person you could ever imagine. Stood up to John when she wanted to, and it was frequent. And he had just ultimate love and respect for Annie as a human being. And sadly, she passed away today at the age of 100 years, which is pretty incredible, just to make it that long. And very, very strong woman. And I think we should all give her a salute here today.
Thank you.
Begins a completely different journey.
Thank you, John. Thank you for that tribute.
You know, so we can only hope Hubble lives 100 years, but 30 isn't too bad. Next slide. When this slide comes up, this is the 30th anniversary picture. One of the traditions of the Hubble Space Telescope is every year the Space Telescope Science Institute, which manages the Hubble Science Program and operates the Hubble Telescope, produces an anniversary image. And this one's called Cosmic Wreath. This kind of looks like, if you look actually down on Earth at coral reefs, you know, they have an amazing green-blue hue. And so this is a star-forming region in the Large Magellanic Cloud. So in the Northern Hemisphere here, we don't get to see this. But if we have any sky watchers from the Southern Hemisphere, this is a familiar object, but probably not in quite this glorious detail. And this is a stellar nursery, and it's being lit up by very hot stars that have just turned on, so to speak. And to the lower left is a star that's had kind of a temper tantrum, and it's blown off its outer envelope, and it's now illuminating that outer envelope. It's called a Herbig-Haro object. But it's just really a beautiful image. And I think this image and many other Hubble images highlights the value of the Hubble Space Telescope, which is amazing science. From images like this, we learn about star formation, about stellar evolution. We learn about how material goes from the inside of stars into clouds and then to reform into stars, the life cycle of stars. How planetary systems form, because what we learned studying in detail is that when stars like this form, the stellar material circling that star forms at about the same time and planets form at about the same time. So incredibly scientifically rich. But it also shows something that before Hubble we didn't really, I think, appreciate, which is that the universe is a more beautiful and dynamic place than we ever imagined. Just this could be a piece of modern art, that would sell for, hundreds of thousands of dollars at an auction, if some famous artist had painted it. But yet this is nature, and we see this all over the universe. And the Hubble has been the primary mechanism by which we have, been able to show people around the world the wonder and awe of the universe, the beauty and richness in the universe. Next slide. This is an image of the aft flight deck of the Space Shuttle. You can see the Hubble Space Telescope out the windows. And 11 years ago, I was on orbit on the Space Shuttle with my crew. I'll introduce them in a moment. And one of the items we got to bring with us was a replica of Galileo's telescope. And it just shows that in roughly 500 years, how far humanity has come from somebody taking a telescope, Galileo, and observing the skies with it, to the Hubble Space Telescope, and being able to build a space shuttle to go up to space to be able to service that Hubble Space Telescope, and how much we've learned. I mean, it's really incredible that just in the last 100 years, from Edwin Hubble observing on a 94-inch telescope to the Hubble Space on a 100-inch telescope to the Hubble Space Telescope, which is only about 94 inches across, that we've been able to put together a story of the origin of the universe, a Big Bang, to the expansion of the universe, to the formation of galaxies, of black holes, of planetary systems, all the way through the formation and evolution of the Earth in just 100 years is pretty incredible, using observatories like the Hubble Space Telescope. Next slide. The Hubble Space Telescope is not a particularly large telescope by astronomical standards. It's 2.4 meters across. If you hit the next button, the stats will come up. It weighs about 25,000 pounds. But by being above the atmosphere, we get a clear view of the universe. The atmosphere makes things look fuzzy because the atmosphere is moving. As well, certain types of light, ultraviolet light, for instance, don't make it down to the surface of the Earth. And so we just can't see it. There aren't ultraviolet telescopes on mountaintops because the ultraviolet light doesn't make it through our atmosphere. And so the Hubble's perch in orbit gives it an unfair advantage over big telescopes on the ground, but that's okay. They work together for us to learn about astronomy. The Hubble Space Telescope, as I said, has been up there for about 30 years. And, we use the word Hubble as a kind of superlative. So when we talk about, the Hubble of particle accelerators or the Hubble of, cars or things like that, we mean, the best thing possible. Next slide. Using that word, though, we forget about Hubble's its infancy, when it first got to orbit. This is one of many cartoons that appeared early in Hubble's history. And it says, first photos from the Hubble. And there's a picture of a distorted moon, looks kind of like a peanut, Jupiter, Saturn. And then if you were to turn the Hubble down on the ground, you would see very angry taxpayers. And that's because when Hubble was launched and they took the first images, astronomers realized that something was horribly wrong. And it was determined pretty quickly that the mirror had something called spherical aberration. And what that means is that the prescription of the mirror, think of, wearing glasses, was slightly incorrect and the images were fuzzy. Fortunately, by interrogating the images, astronomers and optical engineers were able to figure out what that wrong prescription was and fix it. And so on the first servicing mission in 1993, the crew brought up contact lenses, in effect. In fact, they were mirrors, but that doesn't matter. The mirror corrected the spherical aberration. And ever since then, we think of Hubble as the greatest thing ever. Next. So as I said, 11 years ago, I was on orbit with this crew. The crew is commanded by Scott Altman. It was his fourth mission. He's an aerospace engineer and a Navy captain. He was the commander on the mission, and he had flown also with me in 2002 to the Hubble Space Telescope, so he was a Hubble veteran. To his right is Megan MacArthur. It was her first flight. She's an oceanographer and an astronaut, obviously, and she was our robotic arm operator and flight engineer. Of course, to her right is myself on my fifth mission, my third mission to the Hubble Space Telescope. My spacewalking partner, Drew Feustel, to my right, was on his first flight, and he's a geologist, exploration geologist. He's still active in the astronaut corps and returned last year from the International Space Station. To Scott Altman's left is Greg Johnson, an aeronautical engineer and also a Navy captain. And he is now at Blue Origin, and he was our pilot. To his left is Mike Good, Air Force colonel, flight test engineer on his first flight, also at Blue Origin now. And he was a spacewalking partner with somebody you probably have heard of, Mike Massimino, Astro Mike, if you follow him on Twitter. And he was on his second flight. He flew with me as well in 2002. So we had a mix of Hubble experience and first-time flyers, but you wouldn't know it on orbit. Everybody did just really well getting to orbit, training, and fixing the Hubble. Next slide. Once we had to launch. This was the first time I'd been on a day launch. My previous 4 missions had been night launches, so that was a different experience, but still the ride to orbit is incredibly dynamic. really a pretty exciting thing to do. And we flew after the tragic loss of Columbia. And by not going to the space station, we didn't have a rescue option to hang out at the space station. So there was actually a second shuttle on the other launch pad, just in case something happened. Theoretically, they could come to rescue us. I think mostly it was to show that NASA was doing something just in case something went wrong, rather than just ignoring the risk. But nevertheless, we had that sort of in the background. Of course, once we got to orbit safely, they turned that around to prepare it for the next station mission, as we were safely on orbit. Once we got to orbit, we had to chase down the Hubble Space Telescope. Next slide. And so here, Scott Altman actually manually flying the space shuttle up underneath the Hubble Space Telescope as we got closer and closer. And his job was to get us right next to the Hubble, and with the shuttle basically motionless compared to the Hubble Space Telescope, so that Megan MacArthur, next slide, could reach out with the robotic arm and grab the Hubble. And what I find really fascinating sociologically is when I trained on the robotic arm, we actually had a large hydraulic arm in Houston that I could drive around and practice with. And when Megan trained, we had switched everything to computer simulators, meaning basically she trained how to grab Hubble in a computer game and did it over and over again. So when we got to orbit, it was the first time she got to fly the robotic arm to grab the Hubble Space Telescope, pick your number, $8 billion international resource exploring the universe, one of a kind. And if she bumped it accidentally instead of grabbing it, it would go floating off and we probably wouldn't be able to get it back. So just from safety and power and other things. So she had a lot of focus and she did a great job. Next slide. She successfully grabbed the Hubble Space Telescope, and with that we put the Hubble into the payload bay of the shuttle. And this is kind of a window with a view, which all of us, who are inside from COVID-19, I hope you look out the window and realize there is an outdoors there. And in space, this is one of the overhead windows on the space shuttle, giving you a view of planet Earth. Once we had the Hubble, the next day we were ready to do our spacewalks. Next slide. And this is what I really love, is to get into a spacesuit and go outside. And I think you can see, hopefully, that I have a big smile on my face. And anytime I'm outside in the spacesuit, and almost all the time in space, I have that silly grin on my face because it is just so special. And here, if you look in my helmet, you can see the Earth reflected in my visor. And behind me is the space shuttle wing. To the left is some of the gear that we bring up to service the Hubble Space Telescope. And the amazing spacesuit. The spacesuit is really a full spaceship in itself. In the backpack, of course, there's oxygen. There's a backup oxygen supply. There's batteries. There's a little canister to absorb carbon dioxide as I exhale. And of course, a helmet. And so you get the wonderful view out just the piece of plastic and the helmet. The helmet has cameras, so you can see what people inside the shuttle and on the ground can see what we're looking at and working on. There's helmet lights with high and low beams, and the batteries are so good now we just leave those on all the time. And then in front of me is my tool belt, and everything on that tool belt has to have a tether so you don't lose anything. Because if a tool floats away, that'd be really bad. Not to mention that you wouldn't have the tool to fix something, but eventually that's going to re-enter, and you wouldn't want it to hit that high-flying airplane we call the International Space Station. So we were trained if we let go of a tool to say, look out below. But fortunately, on none of my Hubble missions, and we really trained this hard, we didn't lose a single tool or object out of the space shuttle. Next slide. Now, one of the reasons I was so happy is on this first spacewalking day, our job was to change out the Wide Field Camera 2 that was put on in 1993 and replace it with the super duper Wide Field Camera 3. And it sounds like one upgrade, but Wide Field Camera 3 incorporates the best detectors, the best cameras that were available in 2009, and in fact are still pretty much state of the art. And it had two channels, a visual channel like what we see and an infrared channel. So really a major advance for Hubble, something that really promised to explore new realms. And one of the easiest tasks that we do on Hubble. I mean, there were two bolts you loosen, you pull it out, you put the new camera in, you tighten the two bolts, and you're done. So I was pretty happy that we were heading out, to go put in this new camera, revolutionize astronomy. And when Drew went to loosen the bolt, he couldn't get it loose. It was too tight. And we really sweated that for a long time. And I was thinking, this is the one time I've been out spacewalking and I was not smiling. I thought, I cannot believe we came all this way. That the Hubble project was canceled, that we got it back, that we survived launch, we got to orbit, and now we can't get the old camera out. And, fortunately, the ground gave us the go for Drew to apply a little elbow grease beyond what torque was normally allowed, and he was able to loosen the bolt. But it was tense for a little while. So that's a picture of Drew Feustel on the end of the robotic arm, playing with a wrench, and I'm floating on the telescope to his left, not smiling, until we can get that old camera out and the new one in. But fortunately, we were able to do that with the help of the ground and a little bit of elbow grease from Drew. Next slide. We also replaced the optical correction device. I talked about contact lenses. Well, this is actually the box that held the contact lenses. This is the COSTAR instrument, which is the Corrective Optics Space Telescope Axial Replacement. COSTAR is a much easier way to say it, that had those contact lenses, so it wasn't quite as simple. But we were able to remove that because all the new instruments have that correction incorporated into their own optics. And so we were able to take that out and put in a new instrument called the Cosmic Origin Spectrograph, which is up on orbit now, working great. You can also see that Drew has a death ray laser on his sidearm, that thing with the long tube, as part of Space Force investigations early on. But actually that's a power tool that's basically a power screwdriver. And it's something that Hubble Space Telescope project pioneered. It's now widely used on the ground. It's called a line tool or a wire tool. But that's our general purpose screwdriver wrench. And it's used on basically every station spacewalk now. And so Hubble has been a pioneer for space tools as well. The other thing you notice is that box looks very big, and it is, and it weighs about 800 pounds. So I convinced Drew to go to the gym every day for a year to lift weights. So he'd be able to lift that thing, which is pretty silly because it's free floating, as is everything. So it has no weight in space, but in fact, it does have mass. And so not Mike Massimino, but it has physical mass. And you have to be very strong in the spacesuit to be able to handle big objects like that, because one, the spacesuit provides a lot of resistance. Just to do a bicep curl or something, it's like lifting a 30-pound barbell. And if you get a big box like that moving too fast, you got to be strong enough to stop it, or it'll slip right out of your hands. One thing is move very slowly, but you have to be pretty strong. So spacewalking is actually very much an athletic event. Next slide. We also put in a new fine guidance sensor. We changed the batteries on Hubble. We changed the gyroscopes. We changed some thermal insulation. All kinds of upgrades and repairs to the Hubble Space Telescope, such that when we left it in 2009, Hubble was not only state-of-the-art in terms of scientific instruments, with all of the instruments working, it was also upgraded so that it would have hopefully a very long lifetime. Now, our warranty was 5 years, labor included, and that expired quite a long time ago. But I'm happy to say that everything on Hubble is working well, and we still have a full complement of working gyros. Knock on wood, Hubble can last another 5 or 10 years on orbit. Next slide. So once we were done playing outside, Megan was able to grab the Hubble again, lift it out of the payload bay, everything working, everything fixed, and let go of it so that we could back out from underneath it with Scott Altman at the controls. Next slide. And so we saw Hubble drifting off into the distance behind us, getting smaller and smaller until we couldn't see it anymore. And Hubble has been on its journey ever since. Next slide. The question is, did we fix the Hubble or did we break the Hubble? And this is just an example that says, we fixed the Hubble, and this is an image that's called the Hubble Ultra Deep Field. You've probably seen a picture called the Deep Field, but the Ultra Deep Field is with this new camera. And other than, a couple of stars that are in our own galaxy, and you can see those because they have the little crosses, diffraction patterns coming out from them. I see 2 stars in this image that are in our own galaxy. Everything else in this picture, every speck that you see is a whole galaxy with tens to hundreds of billions of stars. In the original deep field picture, Hubble could see about 3,000 galaxies. There were over 10,000 galaxies in this one picture. And this picture, is, smaller than your pinky. If you were to hold your pinky at arm's length up at the sky, your pinky nail, this picture is an area of the sky smaller than that. And so it's really incredible when you think about, here we are on planet Earth orbiting a rather ordinary small star, very quiet star, in a solar system with, 8 + 1 planets. And, that one star in our galaxy is 1 in 400 billion in our extended galaxy. And there are, just billions and billions of other stars and galaxies out there. And think of how many other Earths are out there, and it's just mind-boggling. There must be many. Next slide. A little closer to home, when I was growing up, one of my favorite constellations was the constellation Orion. And if you look at Orion, it's easy to identify Orion's belt with 3 stars, and then there's a sword that are 3 stars. But actually, that middle star in the sword is not a star at all. It's this star-forming region, or a very bright region of gas and dust, where some of that gas and dust is collapsing and baby stars are being born. And this is what it looks like through the Hubble Space Telescope. And again, this looks like an amazing abstract art creation, maybe from an airbrush artist, but this is real nature. This is what it would look like if you had the sensitivity of the Hubble Space Telescope and a little bit wider spectrum that our eyes could see. Really incredible. And we've been able to study this in great detail, to look at stars, that have just turned on from collapsing gas and dust until it heats up enough that fusion starts. Next slide. Of course, the Hubble doesn't just look at distant things, it also looks at close things. And this is a series of images that were taken by the Hubble, stacked on top of each other. And we have captured in each of those images the moon of Mars Phobos as it moves along in its orbit. But it also shows us that, we think of most planets as being very different from Earth, but here we can see that, there's high-level clouds on Mars, and it just reminds us that Mars has, even though it's a thin atmosphere, has a carbon dioxide atmosphere that has a lot of other components, including trace amounts of oxygen and water vapor. These are not only carbon dioxide clouds, but water clouds. And we have actually seen snow on Mars from our Mars explorers. And you can see that there's different weather patterns. And of course, this is the southern hemisphere winter. We can't see the ice cap at the South Pole in this image just because of the angle. But Mars is a dynamic planet with seasons and weather. Someplace I'd like to go, and I know lots of you on the viewing probably would like to go too. And Hubble has been able to study dust storms and weather and climate patterns on Mars now for 30 years, and we will continue to do so. Next slide. Well, what's up in the future? That's something we'd all like to know. And one of those things that's getting closer to launch, we're now, about a year from launch, is the James Webb Space Telescope. And it's going to be amazing observing Mars. That's going to be just really incredible, and the rest of the universe. So I wanted to put in a plug for James Webb Space Telescope. I think all the pieces have been put together, and they're buttoning it up, getting ready to send it to the launch pad for launch on Ariane 5 next year. There are some interruptions due to COVID-19, but hopefully we get off next year and we can start observing soon thereafter. Next slide. So that's the Hubble story. The Hubble Space Telescope is still very much alive. The story is still evolving. And I like to say that perhaps the most incredible discovery from the Hubble Space Telescope hasn't been made yet and will be made in the future. So Matt, over to you.
Thank you, John. I am so glad that you had those gorgeous images to share with us. Also because in the middle of those, I lost my network connection and was, thank goodness, able to get back on. So the Hubble has been a good deal more reliable than my internet this morning. The science that is still being delivered by the Hubble. I mean, we could spend not just this hour, but hours and hours going through thousands of iconic images. I mean, I've been in the office of a senator who had the deep field on his wall. Everybody knows the pillars of creation, right? It's endless, and they're all gorgeous. It says something about, I think, not just the contributions the Hubble has made to science, but also to the public's appreciation of science. And I mean the public around the world, not just in the United States. Did everyone realize how important Hubble, the contribution that it would make in that area as well, that it would become, as I said, probably the most famous scientific instrument of all time?
Well, Hubble, I don't want to make it sound like a cult, but Hubble really may well be, by almost any metric, the most productive scientific instrument humans have ever created to date. And again, I credit the amazing engineers who designed it, the ability of astronauts to go up and service it, that longevity has allowed us to unravel the mysteries of the universe as much as it has. I don't think it was well appreciated how Hubble would share that wonder and awe of the universe with the general public. And that's because before Hubble, we didn't really know how beautiful the universe is. We hadn't had that experience. The best images on the ground did show, incredibly colorful, fuzzy objects. But it's when you have the resolution of the human eyeball or better on the universe that you start to go, wow, that's really beautiful. That has depth that inspires, us to think about the universe we live in a way that we never thought before. I think most people before that thought, yeah, the universe is filled with stars, little points of light, and some planets, and the planets are interesting, but not the beauty that we see with the Hubble Space Telescope.
With all of that work you did for NASA, I mean, you followed that with a stint at another organization that everybody knows, the Hubble, but they may not know one of the organizations behind it, the Space Telescope Science Institute, where you were deputy director. Could you say something about what the Institute does and the role it's played, not just with the Hubble, but with many telescopes around that are above our heads, a lot of other great observatories?
Absolutely. And in fact, that's the incredible vision of a man named Riccardo Giacconi, who was the person who really put together with the team the concept of having an institute dedicated to operating a great observatory, the Hubble Space Telescope, but providing support for the scientific community to use the telescope. The traditional model is whoever can get the most money together builds a telescope, and the people who are at the institution, like the University of California or Caltech or someplace like that, they get to use the telescope, and if they're really nice, they let other people use the Telescope. And the Hubble Space Telescope has been called the People's Telescope.
Hmm.
You know, almost anybody in the audience today can propose to use the Hubble Space Telescope. The challenge is, if you have to learn how to operate the instruments on the Hubble and calibrate the data and remove the effect of cosmic rays, and understand how to command and what filters to use and so on, the technical detail, it would be very challenging. And so Riccardo Giacconi's vision was that there would be a group of people, and they called it the Space Telescope Science Institute, that would operate the telescope and would also support users by performing those calibration activities, removing the cosmic rays, fixing the defects in the detectors, all the behind the scenes stuff that's really very tedious and would have to be replicated over and over and over again by every scientist. Instead, the Institute, provides the research support so the astronomers can concentrate on the science. And this was at the time revolutionary, and there was a lot of pushback, and it took a lot of convincing, and was done long before the telescope was launched. And so it was a grand experiment. Build a telescope, that anybody can propose to use, and a research institute to support those scientists. And it has been an extraordinary success. It's one of the reasons why Hubble produces more than 2 scientific peer-reviewed publications a day, because the scientists can concentrate on the science. And so if myself as an observer, personally, I'm using the Hubble Space Telescope on a project with Bill Sparks at SETI Institute to observe plumes of water around the moon Europa around Jupiter, with the Hubble Space Telescope. And if we have a technical question, we call up one of the supporting people and they help us solve it. We don't have to figure it out on our own. And so the Space Telescope Science Institute was that experiment, extraordinarily successful. It will also be used to control and manage the science program for the James Webb Space Telescope. But because of its success, it was also replicated for the Spitzer Infrared Telescope. And at IPAC at Caltech, they have a mini Space Telescope Science Institute. When the Europeans decided to build the most powerful ground-based observatory ever, called the VLT, it's actually 4 telescopes that they operate in the Southern Hemisphere. They built a telescope institute to manage that the same way of the space telescopes. So now in Europe, observers don't have to learn about how to use the telescope. They propose for the time, it's selected, and they have people down at the telescope who perform the observations for them, although they can go, and help them with all of the use of the instruments. The Atacama Large Millimeter Array, a radio telescope, uses that model. So that's been replicated now and is the standard model for how to do science, at least in the astronomical realm. And very often there are studies done to try and replicate that. For instance, the CASIS Institute for the International Space Station, they tried to build a model like that. It's such different science and different application. It's had a lot of troubles, but people try and replicate now the Space Telescope Science experience elsewhere because of its great success.
Definitely a part of the Hubble's legacy, along with the Institute itself. We're going to be getting to questions from you folks who have joined us for this Explore Mars event in just a couple of moments. They are, as expected, coming in pretty rapidly. We'll get to as many as we can. We do have to end on the hour today because John has another commitment. But we'll collect those and Explore Mars will hang on to them, and hopefully we'll be able to do something with those questions that we don't get to. I got
Matt, I'm happy to work with you and Chris Carberry to try and answer those by other means after the call.
That's terrific. Thank you. That's very generous. I got just one more for you. You're an astrophysicist. You have often worked outside of the range of visible light in the electromagnetic spectrum. And as you said, the Hubble goes a little bit into the infrared, a little bit into the ultraviolet, but other instruments like Spitzer and as far out as X-rays, right, Chandra, and cosmic rays. These advantages of working across the electromagnetic spectrum from space, this is just going to continue, right? I mean, we're not, you mentioned JWST, but the future for astronomy from space, in space, is pretty bright, isn't it?
I think we are, folks talk about budget challenges and, we can't do this mission and we can't do all the missions. And that's true, but I really believe that we are entering a truly golden age of astronomy and astrophysics and our knowledge of the universe, in that, we do still have Hubble. We're about to launch James Webb Space Telescope that opens up a whole new realm where we haven't explored very much yet at the high resolution and in the spectroscopy and breaking the light into its component parts. So James Webb will really be, like having another Hubble in a new realm. But at the same time, we're opening up, different areas. I think the Atacama Large Millimeter Array, which is a radio telescope array, international project, is the Hubble of radio astronomy. The first light has already occurred, but the Daniel K. Inouye Solar Telescope on the island of Maui in Hawaii is the Hubble Space Telescope of solar astronomy, and is going to give us the most detailed views of our own star, and teach us probably more about stellar astrophysics than much of what's happened, because now we can see things at the scale of the magnetic fields on the photosphere of the sun and study that. We're about to build something called the Large Synoptic Survey Telescope that's going to scan the whole sky every few days, and is going to be able to look at transient phenomena that we've never had access to. And a whole host of other observatories, not the least of which is, we're now entering for the first time in human history the realm of gravitational wave astronomy. And the general topic is multi-messenger astronomy. This is one of the things that Hubble pioneered, is working with Hubble and Spitzer and Chandra, all of the great observatories, to put together, the story about how things work in space. And it's only getting better as time goes on.
A bright future indeed. As you've demonstrated brilliantly, Hubble was built to be serviceable. We're getting questions from a number of our viewers, Patrick Harper, Andrew Planet, that I'll try and consolidate a little bit, asking about, like, JWST, will it be serviceable? I happen to know, no, it won't be, largely because it's going to be far away. But do you, in general, see that as a lesson for the future, that we should be building these great instruments and other things in space? I mean, the ISS is an example, so that humans can go out there and upgrade them and repair them.
Well, I have a slight twist on that, which is, yes, I actually think that, when we invest billions of dollars in an observatory, not just a simple experiment, but something that's multi-purpose and we want to last a long time, that it ought to be serviceable. And that decision on James Webb was made very early on. And there are a number of reasons why that decision was made. One of which is James Webb Space Telescope's going, almost 1 million miles away from Earth, and it was imagined, well, nobody could get out there. But the other part of it is it's a cryogenic telescope and very delicate. To be able to be, half, the mass of Hubble, you had to make a lot of trades in a very lightweight telescope. And it turns out that, especially the sunshade that James Webb Space Telescope has to block the sunlight and earthshine from the telescope so that it can cool down, is extremely delicate. And so if you were to try and approach it, say, with the Space Shuttle, which could never get out there anyway, but just the plumes from the little rockets that slow us down would probably cause that sunshade to fold up, and that would destroy the telescope. So its inherent design is not serviceable, and it was never intended to be. But I think future spacecraft should be, and in fact, Congress agrees with that. They actually put into an authorization act of NASA that future observatories, they have to consider servicing. And as an example, the Wide Field Infrared Space Telescope that's currently being designed is being designed to be serviced, but not necessarily by humans. For simple things, robots are perfectly good at turning a bolt, removing something, putting a new object in, and turning the bolt again. And WFIRST will also be 1 million miles away near James Webb. And so it's perfectly appropriate that a robot could go out and put new batteries in or change out a scientific instrument, or even better, refuel it so it has a longer lifetime. And I think a combination of those modes is what you want. You know, if something is dull or really dirty or very dangerous, you know, let's send a robot. And robotics is making enormous strides. We're going to launch a mission, was called Restore-L, now it's called OSAM-1, to go refuel a satellite in just a couple of years. And it has robotic arms, and it's going to demonstrate, you know, building things. So I think we're going to see on-orbit assembly and servicing take on a bigger and bigger role, you know, as time goes on, as we have more capability. And certainly, if we're going to go to Mars, we're going to want to assemble a spaceship first to go to Mars in. And so we need how to learn how to do that, as we did by assembling the International Space Station. On the outside of the International Space Station, we routinely use the robotic arm to replace components with no spacewalking at all. The ground controls it.
And of course, we're only a couple of months away now from the next smart robot headed to the surface of Mars, Perseverance. Here's a tough one for you, John. As we head into the last few minutes we've got here, we'll see how many more of these we can get through during the hour. This is from Jesse, who's an 11-year-old student in Virginia. Did John ever make a mistake in your maintenance of the work and upgrades of the Hubble Space Telescope that caused any kinds of issues? I mean, anything that ever happened up there that you kicked yourself about?
So there's two ways to answer that, and thanks for that question. If you look, I don't know if my hand, the way the Zoom works, it makes my hand disappear. But if you look at the end of the Hubble Space Telescope, on the left side of my picture, there's a little white dome on the very back of the telescope. And that's called the low gain antenna protective cover. It's a fiberglass cover. And that cover is there so that if an astronaut is out spacewalking on the Hubble, like me, if you bump into it, you don't damage the low gain antenna, which is very delicate. And actually on our mission, we did 5 spacewalks, and Drew and I, you know, were highly trained. We did 3 of those 5 spacewalks, and you know, we pretty much went through all 3 spacewalks, doing everything we were supposed to do and a little bit more, and we didn't make any significant mistakes. And at the very end, the top of my helmet bumped into that antenna after I'd taken the protective cover off, and you know, broke the tip off of it, which is another protective cover, which we grabbed the floating away tip. Drew captured that, but we had to go back out. I had to go back out and put that antenna cover on. And I kind of think it was destiny, because the people who managed the operations of the telescope had to manage the temperature of that antenna all the time because it would overheat. And when we put the protective cover back on, which was not intended to be left on the telescope, their thermal problems went away because the outside of that cover is white, and now they don't have to manage that anymore. And it really didn't affect the transmission at all. So I kind of think like Hubble reached out and wanted that.
Well, Jesse, we're only human and space is hard. And because we're human, we have the smarts and the ability to recover from things like this, as you just heard. Here's a question that came in actually before we started the hour from Mike Helton. Let's see, he's talking about, well, he's got a couple here actually. He's wondering about preserving the Hubble and why there isn't consideration for NASA to boost it into a higher orbit for storage for 100 years or more for future generations, because it'll gain in value over time, he says. I mean, is there any thought about the distant future, hopefully distant future of Hubble when it finally is no longer operational?
Well, like all satellites in low Earth orbit, and Hubble is orbiting about 600 kilometers above us, there is some atmospheric drag. And so over time, Hubble will slowly spiral in to our Earth's atmosphere. And it's currently estimated, because our sun has been incredibly quiet, that sometime in the mid-2030s, there'll be enough atmospheric drag on the solar panels and on Hubble that it won't be able to be an operable observatory anymore, even if everything is working on it. The atmospheric drag will cause enough disturbances. To cover that eventuality, inevitable eventuality, there is on the books a mission to Hubble, probably robotic, to install a deorbit module, which is a little rocket motor that will deliberately target Hubble into the Pacific Ocean so it doesn't hurt anybody. There's no reason why you couldn't use that same robotic mission and motor to send Hubble up to a much higher orbit, and it wouldn't take much more altitude to put it in 1,000 or 10,000 year orbit. The atmospheric drag drops off very quickly. And then it could be sort of a museum piece in space. Now, that's not without risk. First of all, you're deferring the problem to later generations, but I hope our space exploration plans are such that, you know, space travel becomes routine by 10,000 years from now, you know, given our progress to date. If not, we're in big trouble for other reasons. But boosting Hubble does defer that problem to later, and there's always the risk of a satellite-satellite collision. You know, Hubble doesn't have any propulsion to move away from an oncoming object. And so anything you leave in space is a potential problem from space debris and things hitting it. So that is a concern. But there's no reason you couldn't boost it to a higher orbit. That's a policy decision.
Be nice to see it sticking around as long as the pyramids for our descendants to marvel at. We're really out of time. I do apologize that we weren't able to get to a lot more questions, but there's one more that I want to squeeze in because it's from 8-year-old Zoe in Colorado Springs, who says, by the time I'm a grown-up and working with space telescopes, what kind of telescopes will I be working on if James Webb is then 30 years old? And she says, thank you, John. What's way out there beyond? What would you like to see 30, 40, 50 years away in space doing science for us?
Well, thanks for that question, Zoe. And in particular, because I grew up wanting to be a scientist and then in high school wanting to be an astronomer. And I assumed, of course, that by the time I grew up and went to college, went to graduate school and became an astronomer, that all astronomers would go to space. It just seemed like, well, you know, astronomers go to mountaintops, but space is the place to be. So, you know, I wanted to be an astronaut and go to space, but I thought it would just be a natural consequence of me being an astronomer. And so really surprisingly, it worked out for me, but it's not the norm, certainly. And I hope for you that it will be, that space, although it will always be very dangerous, becomes more routine in the sense of access. And, you know, who knows, maybe if we can boost the Hubble will still be there. But my vision, my dream, is that after James Webb and the things we have planned now, that we'll be bold, and that we will decide to build a 16 or 20 meter telescope. And by build, I really mean build, that robots and/or robots and humans will assemble it, because that's too big to put in a single rocket. That we will assemble a telescope that's big enough, and it takes 16 to 20 meters, that we will be able to look at the nearest 100 or so sun-like stars like our own sun, to observe planets around those stars that are in the habitable zone and see if anybody's home. And that takes a 16 or 20 meter telescope, much, much bigger than Hubble, a little bit bigger, you know, 2 or 3 times bigger than James Webb. And in fact, you know, one of the things I'm working on now is the technology with others at Goddard Space Flight Center, JPL, at various companies, to design the technology to assemble a telescope like that, because it's a very practical thing to do. I'm convinced that in a couple of weeks, you know, myself and a couple of other astronauts could assemble such a telescope with robotic support. We just have to make sure the technology is there, that it would actually work. And lots of people are working on that. And I think this is a kind of a extra detail, but the decadal survey for astrophysics is planning on what investments do we need to make and what do those future telescopes look like that we should start in the next decade, so that when you grow up, You can either go up and assemble that telescope, or perhaps be an astronomer and use that telescope to unravel further mysteries of the universe.
What a great vision. Thank you for sharing that with us, John. Thank you for this past hour. And for that matter, for helping the Hubble to continue to share its vision for perhaps years to come. This has been as delightful, maybe more so than I expected. It is always a pleasure to talk with you. And,
Thanks, and to everybody out there, please stay healthy.
Yeah, absolutely. And I need to get you out of here. So we will thank the rest of you for joining us as well with the great John Grunsfeld of NASA and Astronaut and other science-related fame. There is another one of these events, as you heard Chris Carberry say up front, on Thursday with Jonathan Frakes, a pretend astronaut, but one who did impressive work on Star Trek, continues to actually. Check out ExploreMars.org if you want to learn more about that upcoming event and this entire series of virtual events from Explore Mars. I want to thank everybody who's been a part of this today, all the folks like Janet Ivey, who's been feeding us questions, consolidating them, Wade Holler, who's been directing the show, and of course, Chris Carberry, the CEO of Explore Mars, who stands behind all of this. Again, I'm Matt Kaplan. I hope you'll join me for Planetary Radio, where for 17 and a half years, over 900 shows now, we've been bringing you the best of space exploration and space science. And John, I'll just say thanks once more and wish you a great and very safe, happy day.
Thank you very much, Matt. It's been a real pleasure.
Take care, everybody. Ad Astra.